To clip 2 of your introduction to trigonometric proofs. So in clip 1 we reviewed all the properties that are in there, the odd-even identities, the cofunction identities, the Pythagorean identities. We're going to be using these along with our reciprocal identities also. We're going to be using those to do proofs with trigonometry. All right, so we're going to be doing proofs with trigonometry. They're going to start out pretty easy, just using some of the basic identities, and then from there it's going to involve fractions and even factoring. So when I say that, I'm just going to give you a couple of examples real quick that are not on the notes. You might add them to the back of the notes if you have room. Down where it says homework 1 through 10, that's not the assignment, so maybe you do that there. For example, we have, right now we have sine squared plus cosine squared equals 1. Well, if I solve for sine squared, I get 1 minus cosine squared theta. Well, if you remember the difference of perfect squares, like x squared minus 16 is x minus 4 by x plus 4. When I have sine squared, and I'm trying to do something with it involving cosine, maybe one of my fractions involves something like 1 plus cosine theta, or 1 minus cosine theta. And I have this fraction, I have the fraction involving trig expressions. And I want to cancel these out, and one of my expressions is sine squared, I can change it to 1 minus cosine squared, because that's a Pythagorean identity. And then I can factor this as 1 times 1, cosine times cosine, plus and minus, using the difference of perfect squares. And then if one of those appears in the other part of the fraction, I can start canceling factors because they are the same factor. I also have to remember my rules of fractions, right? I can't just say, hey, I've got x and x plus a, and then in my denominator I have x plus a plus b. Well, I can't cancel my x and the a because this is not a factor. This is its own factor. Those would not cancel. However, if I had x and x plus a, and x plus a and x plus b, then I could cancel a factor. Basic rules from rational expressions from Algebra 1, and we reviewed some of them in Algebra 2 earlier this year. Let's go back to starting our trig proofs. The trick to doing the trig proofs, and what we're going to expect of you, is that you lock one side and you do everything you can to the other side to make it equal the exact same thing you see on the other side. I'm going to start by locking this side. Now, there's multiple ways to solve these, and sometimes you start on one side and it doesn't work, so you have to erase and go back and fix it. This one I know is going to work. I'm trying to turn this side over here into secant so that I can say, hey, look, I got secant, which is what this is. So I did it right. I've just proven it using algebra and trig identities. When I look at these, there's not a Pythagorean identity because there's nothing squared, right? For our Pythagorean identities, it has to involve sine squared, cosine squared, one of these trig functions squared. So whenever I see a squared, I'm going to start thinking Pythagorean identities. I don't see that in here. I do see tangent and cosecant. I know that tangent can be written using one of its identities as sine theta over cosine theta. Well, that doesn't really help me yet. But I also know that cosecant is the reciprocal of sine, and it can be written as 1 over sine. So when I multiply, I have the product of these two fractions. I have one factor of sine in the numerator and one factor of sine in the denominator. This gives me a remaining ratio of 1 over cosine, which, if I use its reciprocal identity, is secant. So starting on one side, I said, well, what do I know about tangent? What do I know about cosecant? Can I do anything with those? Hey, it reduced. Great, that's helpful. 1 over cosine is the reciprocal of secant, so I wrote that, and then I now have that those two things are the same. On this next one, you can pick either side to start solving from. I actually distributed here initially and did some things. Here I could even start on this side. I could say what we just saw. Look at this. Sine squared is 1 minus cosine squared, which is 1 plus cosine and 1 minus cosine. Well, that's what I have here. So that would work. I could start on that side. I'm going to start on this side, though, since we already kind of saw that with the other example. If I actually go through and distribute this, distributing doesn't always work, but sometimes it does. This gives me 1 plus cosine x. Then I distribute the negative cosine. I get negative cosine x minus cosine squared x. And if you look at this, these are opposite terms, so they're canceled. I have 1 minus cosine squared x. What am I trying to get to? I'm trying to make it sine squared x. Well, wait, isn't this a Pythagorean identity? Right now you might not be sure, so you're keeping these handy. I know it is. Let's flip back and see. Sine squared plus cosine squared equals 1 is the one I've memorized. Sine squared is 1 minus cosine squared. So when I have this, 1 minus cosine squared, that is sine squared. So those work. So I worked my way down. I did something to get from here to here. It was some distributing. I combined like terms to get from here to here. And then I said, hey, I think I know what that's equivalent to, and I wrote it down, and now I can check them off. I'm not going to make you do proofs in terms of writing, distribute, combine like terms, Pythagorean identity, but I should be able to follow your work as you go down. Should be able to follow exactly what you did as you go down because I know the identities and you're memorizing the identities. All right, our next one is, this is my equal sign. See how this thing's bigger and uglier on the left-hand side? When I'm doing a proof, I usually start with the bigger and uglier side because I'm going to try to simplify it to something simpler. If it doesn't work, then I go back and try to do it the other way. So with this, yikes, this is crazy. Now I do see that this is two terms and that there is sine in both of those terms. So I could, if I wanted to, factor out sine. I don't think that's the best idea. I could do that. It may work, it may not. I'm going to do something a little bit different. I'm going to start with, hey, these things are, I know cosine squared, that's a Pythagorean identity. This has a Pythagorean identity. These really don't. So I'm not going to worry about, I'm going to see what I know about cosecant. Because that's the thing that's weird. That's not part of the Pythagorean identity of sine squared and cosine squared. So that's really 1 over sine of x. And I am multiplying that, hey, times sine of x minus sine squared theta, or of x, equals cosine squared of, well, I'm not doing the equals, I'm just doing on the right left side. So, wait, 1 over sine times sine over 1 is 1. 1 minus sine squared theta. Hey, that looks familiar. I know what it is, maybe you don't, but you see that squared, so you go back to your Pythagorean identity, and you see that cosine squared theta is equal to 1 minus sine squared theta. So I can say, well, using the Pythagorean identity, I don't have to write that part down. This is cosine squared theta, which is what I was trying to prove, so I can check that off. This one, I didn't say what it was because I wanted you to know what it was going to be equal to. We're going to lock this side. I'm not telling you what it is because we're going to get there. So you're going, what? What does that mean? Well, this, we recognize this as a cofunction identity. In fact, cotangent, we didn't write these down the other day, which is why you might not. This is tangent of pi over 2 minus theta, and tangent is cotangent of pi over 2 minus theta. And so I will recognize that as tangent of x. Using the cofunction identity, this gives me sine of x over, that becomes tangent of x. You're like, well, okay, I'm trying to get this down to one thing though. So I didn't tell you what it was. I will tell you what it is right now. I want it to be cosine of x. We're going to prove that this stuff, there was all this crazy stuff over here, so we started with that side. We said, what do I know about this? I know it's tangent. Well, I don't want it to be cosine. Right now I have sine. I will not be able to use a Pythagorean identity, at least not right now, and I don't think I want to. Neither one of these is squared, so Pythagorean identities are out. Reciprocal identities are still good. Cofunction identities, we just used one. I know the reciprocal of tangent, so this is really sine of x over, the reciprocal of tangent is sine over cosine. Well, how do we divide by a fraction? We multiply by the reciprocal. So I have sine of x times cosine of x over sine of x. Well, if I have sine of x over 1 times cosine of x over sine of x, I have one factor of sine x in the numerator, one factor of sine of x in the denominator. This will give me cosine of x, which is what we were trying to prove. I didn't tell you that, but I did later in the thing. Oh, don't worry, on the proofs that you're given, there will be an equation. You will see what is it you're supposed to prove on one side or the other. These last three are a little bit more involved, and they are past the level of what you should need for the very first level that you're working on of trig proofs. So I will come back and do these either in class when we next meet, or I will put a clip 3 up sometime next, before the next class period or at the next class period for you. So hopefully this helps you see. Remember, as you do your guppy level, you have to lock one side of the equation and try to change things on only one side, following the trig identities, to try to get the same thing on the left that is given on the right. Or it could be the reverse. Maybe you're trying to get the same thing on the right that you already have on the left. Have a great day.